The Carrier Mist 2 project seeks to implement a water mist system on a 30xV condenser. This is a continuation on the previous Phase 1 team that was not able to finish due to COVID-19 and other extenuating circumstances. This system shall be prototyped and tested at the Carrier facility as well as Unity Charlotte facility. At the virtual kickoff meeting back in September, the team received a list of requirements similar to the previous team's task for the project. The main requirement being the device must be driven by a code that will determine when the system is beneficial to turn on and off. This decision-making for this process will be driven by the EASE code, which has developed a parametric table containing various temperatures and relative humidity. EASE has been driving many of our decision-making and will continue to drive many other decisions as testing continues and data is collected. Revisions to the EASE code will be adjusted according to a better model of the system. The principle of evaporating water droplets absorb heat energy. The heat from the surrounding air is lost to the evaporating water and thus lowers the temperature of the surrounding air. For different temperatures and increasing humidity, the water flow rate must decrease as the amount of moisture content the air can hold decreases. This graph shows the net savings of a 200 series 30xV chiller running at full load and increasing relative humidity. We can observe a diminishing savings as the relative humidity increases for any temperature range. The EASE code calculates how much water must be introduced to take the dry bulb temperature down to its wet bulb temperature. The energy saving of an evaporative water mist system can be very significant if sufficient water can be evaporated. The system is used to chill coils on the 30xV chiller. It begins work by taking in water from a water supply source. This water then gets put through a globe valve where the pressure into the system is reduced. From here it goes to a pump where we control the amount of water going into the system. The water moves to the filtration system, control valve, and to the nozzles where the water is then atomized before reaching the condenser coils. This setup utilizes stake pen style atomizing nozzles. These nozzles allow the pressurized nozzles to atomize the water exiting the orifice by impacting the pin at higher pressures. These nozzles were chosen because of their simplicity as well as low cost. Compared to Phase 1, the team noted that the stand geometry of the initial setup did not match the standard V of the Carrier chillers. The team altered the design so that the stand was taller, as well as having a shorter base, which assisted the mist coverage of each nozzle as they spray in a cone pattern. The main electronic component of the system is the Raspberry Pi. The Raspberry Pi can be coded to collect information from the temperature and humidity sensor, send a signal to the relays to open and close the valve, and turn the VFD on and off, as well as tell what frequency the VFD should run at. With the current 8 nozzle setup, the flow that was experienced from the various inlet pressures correctly corresponds with a theoretical flow rate at 60 Hz. Moving into next semester, the team plans on testing different nozzles. This plan will allow more in the setup, increasing the spray coverage while keeping the overall water consumption low. This is expected to greatly increase the spread of the atomized water. In addition, a more permanent solution of mounting the cooling unit and filters will be implemented. The electrical components will be installed into the electrical box, and data will be collected using these electrical sensors. Big thanks to everybody watching this presentation, and thank you to our Carrier supporters for their continued support.